Alright, it's Niaki Osteozan. So today we are still going on with the series. It's Niaki Chemistry series, and today we are going to discuss on acids, bases, and then salts, right? So we are having topical revisions, exam preparation in all the science subjects. Always remember to subscribe so that you'll be notified. And also, if you happen to have any question, don't hesitate to get in touch so that you can discuss the questions over here for the benefit of others, right? So we are starting by defining the term acid. So an acid is defined as a proton donor. It is defined as a proton donor. So this is the simplest definition of an acid. And then a base is defined as a proton acceptor, right? So this one is a donor, and then this one is the acceptor, right? And then to define a salt is defined as an ionic compound formed when a hydrogen ion from the acid is replaced by a metal or an ammonium ion, right? So it is an ionic compound formed when hydrogen ion of an acid is replaced by either a metal ion or ammonium ion. So this is the definition of the salt, right? So we're going to explain the salts later, but as for now we want to dissect these two, the acids and the bases, right? So we have two types of acids, right? So we have what we call the strong acids, and then we have what we call the weak acids. So a strong acid is defined as an acid which completely dissociates when in solution. It completely dissociates or ionizes. So dissociates when in solution. And then this one, it partially dissociates. So this is the difference between the strong and the weak acid. Same concept from the bases. We have the strong and the weak bases, right? So weak base, it is one which dissociates partially, and then this one dissociates completely. So we have complete dissociation here, and then here we're having partial dissociation. Are we together? So this is what you must understand when it comes to acids, bases, and salt. You should be able to categorize the strong acids and the strong bases, the weak acids and the weak bases, right? So we have examples of strong acids, right? Strong acids. So we have the common acids: sulfuric acid, we have hydrochloric acid, and then we have nitric acid, phosphoric acid, and etc., right? So these are the common strong acids. So what do we mean by the term dissociation? We say it completely dissociates. What are we saying by the term dissociation? So we define an acid as a proton donor, right? So we want to form protons. That dissociation. We want to break this compound, right? That's to dissociate. So we can say it dissociates, or we can say it ionizes for the solution, right? So we are having complete dissociation to give the protons plus the sulfate ion. Are we together? So here we have two protons here, right, to balance the equations stoichiometrically. And then here we are having aqueous, then here we are having aqueous, and then this one aqueous. So this is complete dissociation. We do the same for hydrochloric acid. We have complete dissociation, right? And then we do the same for all the other acids. And then what do we mean by the term partial dissociation? So for example, we are having ethanoic acid. So this is ethanoic acid from organic chemistry, carboxylic acid, right? So it partially dissociates, right? So this simply means to say we are going to have an equilibrium, right? We are going to have a reversible reaction. So a reversible reaction is defined as a reaction which proceeds in either directions, right? So this one is the ethanoate ion plus as the proton, right? So this one, it doesn't dissociate completely, right? And then this one, it does ionize completely or dissociate completely. So this reaction will reach completion, right? And then this one, to attain what you call the equilibrium. The equilibrium mixture. We have what you call the equilibrium mixture. We use the mixture of the products in the reactants. So this reaction doesn't reach completion. Are we together? So it proceeds in either direction. So this sign simply means to say it is a reversible reaction. And then to define a reversible reaction, it is a reaction which proceeds in either either directions. Are we together? So this is the definition of a reversible reaction. So we're going to explain much on this when we are doing equilibria, right? As for now, just appreciate the dissociation. So for all level, we don't want to explain what you call the acid dissociation constant, the base dissociation constant, Kb and Ka, right? You only need to appreciate the definitions of a weak acid and a weak base, a strong acid and a strong base. And to give example, so examples of strong acids, these are the examples, and then examples of weak acid, we have these organic acids, right? Organic acids. Are we together? And then we go on to the bases. So for the bases, we have a strong basis which completely ionizes. So we have sodium hydroxide, the group 1 hydroxides, and ammonium, right? So it completely ionizes to give the sodium ion plus the hydroxide ion. So for the weak bases, we have ammonia, which dissociates in water, right? So we have water as the reactant to give ammonium ion plus the hydroxide ion, right? So we can also define a base as a solution which only contains the hydroxyl ion as the only negatively charged ion. And then we can define an acid as a solution which contains the proton is the positively charged ion, right? Only the proton is the positively charged ion. And then this one only containing the hydroxyl or the hydroxide ion is the only negatively charged ion. Are we together? So these are the definitions you must familiarize yourself with, right? So we want to give the properties of an acid and the properties of the bases, right? So for O level, we go straight to the properties, right? And then we are going to explain the reaction when we are discussing on the salts, right? So the properties of an acid. So we defined an acid as a proton donor, right? Proton donor. This is the first definition of an acid. It is a proton donor, right? So this is what you call the Bronsted-Lowry. An acid is defined as a proton donor. And then the acids, they react with carbonates. They react with carbonates to give carbon dioxide, salt, plus water, right? So for example, we are having limestone, which is calcium carbonate, right, reacting with hydrochloric acid. So we said we are going to obtain salt. So the salt is calcium chloride. So you should be able to write these chemical formulas, and I taught you how to write these chemical formulas. And then we are going to have carbon dioxide plus water, and you simply balance this equation, right? So we are going to have a 2 here, right? And this equation is now balanced, right? Are we together? So this equation is now balanced. And then we go on to the other property of an acid. So an acid reacts with a metal to give salt plus hydrogen. So the reaction between an acid and a metal, we are going to obtain salt and hydrogen. So we are having sodium plus hydrochloric acid to give, as an example, right? Sodium chloride plus hydrogen gas. Are we together? So this is the equation for the reaction. Then this equation is now balanced. Are we together? And then also this one, in terms of naming the reaction, this one is what you call the displacement reaction. So we're going to explain much on this when we are doing reactions, right? Naming chemical reactions. As for now, just appreciate these properties, right? An acid reacting with a metal, we're going to obtain these two, right? And then we go on to explain the other one, which says when acid reacts with a base, we are simply going to obtain salt plus water. So this is what we call the neutralization reaction. So you must know this by heart, right? So it's sodium hydroxide, so our base, plus hydrochloric acid for us to have sodium chloride, the salt, plus water, right? And then we can proceed by balancing the equation, and it is balanced, right? So this is the equation for the reaction. Are we together? So you should know the acids, you should know the bases, and also the other properties of an acid. Acids, they are mainly oxides of non-metals. So we grouped the elements on the periodic table, and we said group 4, group 5 to 7, these are the non-metals. So in group 4 we have carbon, we have silicon, we have germanium, we have tin, and then lastly we have lead. So these two are the metals, and then these two are the semi-metals, and then carbon is the non-metal. So oxides of non-metals, right? So these two are the in between the metals and non-metals. So we have silicon dioxide having acidic properties, giving what you call the silic acid, right? So this is the silic acid, right? So these are anomalies, right? So you should be able to explain the effects of an acid on indicators. So we have what you call the indicators. So indicators, these are chemical substances which change its color on pH changes, right? So they indicate color change, color change on changes in pH, right? So we have indicators. So for O level, you should know the litmus change, right? And then you should also know the methyl orange, and then lastly phenolphthalein. So we have a lot of indicators. We have methyl red, we have bromothiamine blue, we have a lot of indicators, but for O level we only need to know these three, right? So in acidic medium, the litmus paper changes from blue to red, right? In acidic medium, so we use litmus paper which changes from blue to red to indicate the presence of an acid, right? So it's damp, it must be damped, right? It must be wetted to have moist so that we can absorb gases. So we normally use this one when testing for gases. So the damping process, it is done to absorption of gases, so that they can react on the medium. So in acidic medium, they change from blue to red, right? And then we go on to explain on methyl orange. So on methyl orange, in acidic medium, it is red, and then in neutral medium, methyl orange, it is orange, and then in basic medium it is yellow, right? Basic or alkaline medium, it is yellow. Are we together? And for phenolphthalein, in acidic medium, phenolphthalein, it is colorless, and then in basic medium, phenolphthalein is pink. So these are the color changes you should know. So when testing an acid, these are the color changes you should know, right? And then we go on to the bases, the properties of the bases, right? So a base is defined as a compound which when in solution, it is a compound which when in solution contains the hydroxyl or the hydroxide ion is the only negatively charged ion, right, when in solution. So this is the definition of a base. And also a base can be defined as a proton acceptor. So this is the definition of a base, right? So we said acids, they are formed normally from the oxides of non-metals. So the bases, we form the bases from oxides of metals. So all the metallic oxides, they are basic. For example, magnesium oxide, calcium oxide, potassium oxide, and etc. Right? So first you should be able to identify whether the element is a metal or a non-metal using the periodic table, right? So from group 1 to 3, these are These are the metals. Are we together? And then we go on to give the other properties. So we say the basic in nature, right? We say they are basic in nature. So a soluble base, when a base is soluble in water, we call it an alkaline. So alkaline, these are the group 2. So we're going to explain this when dealing with periodicity. And then we have alkali. So alkali, these are the group 1. So in group 2, we only have barium hydroxide, which is soluble, right? And then all the group 1 hydroxides, they are soluble in water. So we are going to explain this when we are dealing with periodicity. Are we together? They react with an acid to give salt plus water. So this one is the neutralization reaction. The ionic equation for the neutralization reaction, we are having the proton plus the hydroxide ion to give water. So this is the ionic equation, and you must know it by heart. You must know this one by heart, right? You must know this one by heart. It is very, very important, this ionic equation, for all the neutralization reactions. If you are given an acid reacting with a base, we have this ionic equation. And for the energetics, it is going to have the enthalpy change of 57 kilojoules per mole, right? It is exothermic, meaning to say it releases heat to the surroundings, right? So you must know this equation by heart. Are we together? So I'm going to show you how to write ionic equations, right? And then we need also to define the term pH, right? We need also to define the term pH. So pH is defined as the measure of a degree of acidity or basicity a substance is of a substance. Are we together? So this is the definition for pH. At times a pH is normally defined as the measure of concentration of hydrogen ions in a solution. So pH is negative log the concentration of hydrogen ion, but this is for A-level stuff. For you guys, you only need to know this definition, right? And then we have this pH meter. We have this pH range. So pH range, it ranges from 0 to 14, right? So we have this neutral point, which is 7. 7 is the neutral point, and then from 7 up to 14, this is the basic medium. And then these are bases which are more soluble. They are going to be in this range from 13 to 14 or from 12 to 14, right? So these are the strong bases. And then here we have the weak bases, right? And then we go on from 0 to 7, right? So here from 0 to 2, we are having strong acids, right? And then here we are having weak acids. So we have defined strong, weak acid, and etc. We have defined this, right? So this is what you must know in terms of pH. Are we together? So you must be able to identify the strength of an acid with respect to the pH measure, right? So you should be able to understand this. And then we go on to the neutralization reaction. So neutralization reaction is very, very important when it comes to O-level chemistry, right? Neutralization reaction. So it is the reaction between an acid and a base. So we are having an acid and a base, and then we say an acid, oxide of a non-metal, and then this one, oxide of a metal. So whenever you are seeing an oxide of a metal reacting with an oxide of a non-metal, it simply means to say we are having a neutralization reaction. So first you should have the understanding of the periodic table. This is the starting point. You should have the understanding of the periodic table. Are we together, guys? So we are having sulfuric acid reacting with a sodium hydroxide to give sodium sulfate plus water. So this one is the liquid, then this one is the aqueous, this one the aqueous, then this one also the aqueous. Are we together? So this is what you should understand. And to balance this equation, we need to have a 2 here, and then also to have a 2 there. And now the equation is now balanced. Are we together? So this is what you call the neutralization reaction. This one is our salt, and this one is the water, right? And then for us to write the ionic equation, right, to deduce the ionic equation, we can use spectator ions. So we have what you call the spectator ions. So spectator ions are defined as ions which are there present in the reaction medium, but they are not taking part in the chemical reaction. So these ions which are there in the reaction medium, but they are not taking part in the chemical reaction, right? So let us use this equation for us to deduce the ionic equation. So we are having the protons, the hydrogen ions, plus the sulfate, right? The sulfate ion, plus 2 sodium ions, and also 2 hydroxyl ion. For us to have 2 sodium ions, and then we are also having the sulfate ions, right? So we only dissociate the ions, the molecules in aqueous phase, right? Don't dissociate the solid in the liquid phase. You must take note of that. So we are not going to dissociate water. So we are simply going to have plus 2 moles of water, right? So we are going to cancel out the ions which are common on both sides of the equation, right? So we're having 2 protons here, and then here we're not having any proton, right? And then here we're having sulfate, and then here we're having this sulfate. So this will cancel out, this will cancel out. And then here we're having 2 sodium ions, and then here we are also having 2 sodium ions. So this will cancel out. So these are the spectator ions. They are there present in the reaction medium, but they are not taking part in the chemical reactions, right? So we are left with 2 protons reacting with 2 hydroxyl ions to give 2 moles of water in the liquid phase, and then in the aqueous phase, and then in the aqueous phase. So we have 2 here, 2 there, and then 2 there. So we can reduce it to H plus in aqueous to give OH in aqueous plus H2O in the liquid phase. So this is the equation for all the neutralization reaction. Are we together? So you should understand, you should know this by heart. You should be able to write the ionic equations. Are we together? So now we want to discuss on the formation of salts, right? So in conclusion of acids and bases, we said metal oxides, they are what we call the basic oxides, and then we have non-metal oxides, which are called acidic oxides, right? And then we have another group of importance which we call the amphoteric oxides. So we have aluminium oxide, and we have beryllium oxide, and etc. So we have the group 4 trained in the group 4 acidities, and we also have the group 4 oxides. So for all level, we don't want to discuss on that, right? We only want to discuss these 2 which are common, beryllium oxide and aluminium oxide. So these, they both have the properties of an acid and bases. They react with both acids and bases. They can act as bases at a given point, and also they can act as an acid at a given point. Are we together? So you should know this by heart. You should know this by heart. You should be able to define the term amphoteric nature and to give the example, right? And you are done for all level. So we can use aluminum oxide, and then the equations. So let us say when reacting with an acid, right? So we have aluminum oxide plus hydrochloric acid to give aluminum chloride plus water, right? So we said it is reacting with an acid, meaning to say it is acting as a base. So this one is acting as a base, right? So we have a neutralization reaction to give salt and water, right? So it is a neutralization reaction, and to balance this equation, we need to have a 6 here, and then to have a 3 there, and then we can have a 3 here, right? And it is balanced. That's when reacting with an acid. And then we go on to have the reaction reacting with a base. So reaction with a base. So when it reacts with a base, it is acting as an acid. So this one is acting as a base here, and then here it is going to act as an acid, right? So we are having aluminium oxide acting as the acid, right? So aluminium oxide reacting with sodium hydroxide plus water to give sodium aluminate, right? So this is in a complex ion, sodium aluminate, right? So we have what we call complex ions in transition elements. We're going to explain much on complex ions later, right? This one now just appreciate these two equations, right? So these are the equations to explain the amphoteric nature of aluminium oxide. Are we together? And then we go on to explain, we go on the preparation of salts, right? So we go on to the preparation of salts. So in preparation of salts, we have various methods. We have the neutralization, and we have explained the process of neutralization, right? So we said neutralization, we are having the reaction between a base and an acid to give salt and water, right? So this is the symbol, the general equation of the neutralization reaction. So here we want to understand how we are going to obtain the salt, right? So we have the steps. So we are having step number 1. So the first step, we are going to choose. So let's say we want to make a sulfate. So we are going to choose appropriate base and an appropriate acid for the reaction, right? So we can choose sulfuric acid plus sodium hydroxide if we want to make sodium sulfate, right? Plus water, right? So first you should be able to understand the reactant particles. Which one is the acid am I going to use, and then which one is the base am I going to use, right? And then step number 2, we are going to mix slowly in correct proportions, right? So we did the stoichiometry and the Moll concept. So we're going to use equal proportions according to the stoichiometrical ratios. We're going to use stoichiometrical ratios. Are we together? And then we are going to use the indicator. Use an indicator. So the process of neutralization, we are going to use titration, right? We're going to have a conical flask, and then pipette a standardized solution, and then we're going to have a burette, right? So we're going to use an indicator to note the end point, right? So we're going to use an indicator to note the end point. So if you haven't checked on our playlist, we have a video fully explaining titration, right? So you should go on our playlist and you have that tutorial fully explaining titration, right? And then we go on to step number 4. We are going to evaporate the resulting solution to crystallize, right? Crystallize the salt. So these are the steps which we are going to use in the manufacturing of salt by neutralization. So you must know titration. You must know titration by heart. You must be able to define the term end point, and also to define the term equivalence point. So we did this in our tutorial where we explained titration, right? And then we are going to move to the other laboratory procedure of preparing a salt. So we're going to react a metal plus an acid, right? So we are reacting a metal and an acid, right? So let us say we are having zinc plus hydrochloric acid to give zinc chloride plus hydrogen gas, right? And then to balance this equation, we need a 2 here, right? So first we need to identify the suitable reagent for the salt which we want to make, right? So here we want to make zinc chloride, so we are going to use zinc as the metal and then hydrochloric acid as our acid, right? So the first step we are going to add the metal to the acid, right? To the dilute acid, right? And then we are going to observe the effervescence sound produced by this hydrogen gas, right? Or we can observe the bubbles, right? So effervescence, they show hydrogen gas which is being produced, right? So the progression of a reaction is notable by this effervescent sound and the bubbles, right? So when we are no longer having this effervescent sound, simply mean to say the reaction is stopped, right? So we're going to filter off any excess metal, right? So we're going to filter any excess metal, and then we carry the evaporation and crystallization method. So we're going to evaporate the solution to crystallize salt, right? So these are the procedures of making a salt using a metal and an acid, and we can do the same using a carbonate. So the reaction between an acid and the carbonate, we are going to obtain salt plus carbon dioxide plus water. So we're going to observe the effervescence of carbon dioxide gas, and then when we're no longer having the effervescence, it simply means to say one of the reagent has been used up, right, and the reaction is stopped, right? So we can then filter off, and then we can evaporate and then crystallize. So the procedure is still the same, right? So what you should be able to do is to write this chemical equation when an acid reacts with a carbonate, right? And then we have also what you call the direct. We have what you call the direct synthesis. So direct synthesis, we're having sodium plus chlorine to simply give sodium chloride, right? So this is the equation. The reaction into balance, we can simply have a 2 here and then a 2 there, right? So this is what you call direct synthesis. And then we have other procedures like precipitation. We have the precipitation method. So for precipitation method, you are simply mixing two aqueous solutions. So we are mixing A, which is an aqueous solution, plus B, which is an aqueous solution, to have C, which is a solid, a precipitate. That's why we are having precipitation. So precipitate, we are having a solid medium, right? We are having a solid, right? Plus D, which is an aqueous. So we are going to observe this precipitate floating on the surface of this aqueous medium D, right? So we are simply mixing two aqueous solutions, and then to obtain one solid and then one in the aqueous phase, right? So examples of these precipitation reaction, we can have silver nitrate. So all nitrates are soluble, right? We can have silver nitrate plus hydrochloric acid for us. So this one is soluble aqueous, this one is aqueous. To have silver chloride, which is a white precipitate, plus nitric acid, which is also in aqueous, right? So this is the equation. And we can also have barium chloride plus sulfuric acid for us to have barium sulfate, which is the white precipitate. So these are the tests for these anions, the chloride and the sulfate ion, right? Plus hydrochloric acid, which is in aqueous phase. So this is what you call the precipitation reaction. Are we together? So we want to explain the method of crystallization, right? So we want to explain lastly the method of crystallization. So this is the best method to obtain a pure salt, right? So we can define crystallization as a technique used to purify or to obtain pure solid crystals of a dissolved salt from a solution, right? So it is a method used to purify or to obtain solid crystals of a dissolved salt from a solution, right? So this is the definition for crystallization, right? And then we have the steps for crystallization. So you should know these steps by heart, right? So the first step for crystallization, we are going to prepare the salt solution. So it's either we are reacting an acid with a base, or we are reacting a base in acid with a metal, or an acid with a carbonate, right? we did the methods of preparing the salt, right? So the next thing, we're going to filter the mixture, right? So if you are having any undissolved substance, we're going to filter the undissolved solid particles, right? And then next we are going to evaporate. We are going to evaporate the water partially, right? To remove the water partially. So we are going to heat gently so that we avoid the decomposition of the salt, right? And the next thing, we are going to cool the solution, right? So the solution is going to cool slowly so that the crystals will begin to form, right? So the solution will cool slowly, and then the crystals will begin to form. And then lastly, we're going to filter and dry the crystals, right? So we're going to filter using a filter paper or using oven. So we're going to filter and dry using a filter paper or using oven, right? Filter paper or oven, right? And we are done. So this is the method of crystallization. So you should know this method by heart. You should know these steps by heart. And then lastly, we want to explain the important aspects of the salts. So all carbonates are insoluble except for the group 1 carbonates, except the group 1 carbonates and those of ammonia. I'm going to say ammonium carbonate, right? And then all nitrates are soluble. So in from nitric acid, carbonate from carbonic acid, right? So we said, so let's say we're having sodium hydroxide plus nitric acid. We're simply going to obtain sodium nitrate, right? Plus water. That's why we're having this nitrate. And then the same thing for the carbonates. Are we together? And then we go on to the next. Silver chloride is insoluble, giving white precipitate. And then we have a silver bromide, which is insoluble, giving a cream precipitate. And then we have silver or lead. So for iodide, we normally use the lead. So it's lead iodide, which is insoluble, giving a yellow precipitate. So these are the colors you must familiarize yourself with. And we are done with acids, bases, and salts, right? We are done.